discrete time unit impulse and unit step sequences. One of the simplest discrete time signals is the unit impulse. Simplest discrete time signal is the unit impulse or unit sample, which is defined as del of n equal to 0. The condition is n is not equal to 0, and another one answer 1. Condition is n equal to 0, and which is shown in figure 1.28 throughout this book. We will refer to del of n interchangeably as the unit impulse or unit sample. Discrete time unit impulse sample in this figure 1.28. Here in x-axis n, here 0 towards minus infinity, towards plus infinity, here n. So in here del of n equal to 0. Condition is n is not equal to 0. Where is n is not equal to 0? Here, not equal to 0. Here n equal to 0. Here not equal to 0. These time these time are these places whenever not n is not equal to 0, but del of n equal to also 0, 0, 0, this 0, this 0. Okay, okay, fine. Then del of n equal to 1. Then when n equal to 0, that time only 1. So here only 0. So in this 0, n equal to 0, del of n equal to 1. So this is the unit impulse or unit sample. Then a second basic discrete time signal is the discrete time unit step denoted by U of n, defined by here del of n equal for unit impulse, unit sample. Yeah. A second basic discrete time signal is the discrete time unit step denoted by U of n. It is defined by U of n equal to 0, 1. U of n is 0 when n is less than 0. U of n equal to 1 when n is greater than or equal to 0. This is the condition. The unit step sequence, a second basic discrete time signal is the discrete time unit step. First we have seen unit impulse sample, unit impulse or sample. Here unit step. So the unit step sequence is shown in figure 1.29. Here the condition is 0, U of n equal to 0 when n is less than 0, n is less than 0. In this x-axis, n here up to n, this side is, you know already, infinity, here plus infinity, minus infinity, here 0. Here when will be 0? When let's see n is less than 0, n is less than, here 0, so your total full n is less than 0. It means here in this area n is greater than 0. Here all are 0 only. This result. This is the result. U of n equal to 0 when n is less than 0. When U of n is 1, when condition is n is greater than or equal to 0. So here n is greater than or equal. Equal means here only. This is the n is equal to n. N is equal to 0. N is greater than 0, start from here. So all are 1. This one. Okay. This is the discrete unit step sequence. So And then there is a close relationship between discrete time unit impulse and unit step. Unit impulse, that is del of n and u of n. So some close relationship is there. In particular, the discrete time unit impulse is the first difference of the discrete unit time step. Particular discrete unit impulse is the first difference of the discrete time step. Del of n unit impulse equal to E of n unit step minus up to here unit step only. So added minus 1. It means this is previous, past, advanced, yeah, advanced one. So happening advanced. Compared to here E of n, this is happening advanced. E of n minus 1. So conversely, the discrete time unit step is the running sum of the unit sample. Conversely, the discrete time unit step is the running sum of the unit sample. That is E of n equal to summation over m equal to minus infinity to plus n del of m. Okay. Running sum of the unit sample. Okay. In this running unit of, here what we are mentioning, in the summation minus infinity to n. So add del of m, how much coming, we have to add. So conversely, this is the time unit step is the running, that unit step is the running sum of the unit sample. Okay. Okay, here we will see. Running of some equation here according to 1.666. N is less than 0. Condition is n is less than 0. Here m 0 tm. Here 0 tm. Okay. Here when n is less than 0, n is less than 0 means here n is, so when n is less than 0, minus infinity to n, minus infinity here. So n here in this area, that is interval of summation here. Okay. Here. So this is the condition. So this is happening here. My m equal to minus infinity n, minus infinity to n, not here, here only n. How much coming? Impulse del of m, because due to this del of m. So how much impulse coming? And then in B, here condition n is greater than 0. It means this is m, this is n, here 0. So n is always greater than 0 means in this here, in this figure B, so here. So it means in this condition 0 n is greater than 0 here. So this area, interval summation. So m equal to this m equal to minus infinity to n, this area. This is the del m. Here also del m. Okay. So add running sum of the unit sample. How much coming? This is the running here. Here n is greater than 0. Here n is less than 0 happened. Since the only non-zero value of the unit sample is at the point at which its argument is 0. Non non-zero value of the unit sample at the point which is argument is 0 means here only 1, even n equal to 0 only 1, remaining all are 0 only value, remaining all are 0 only. Here also when n is less than 0, when n is greater than 0, here also 0. When n when n is equal to 0, that time only gm is 1, gm value is 1. So that one here, since the only non-zero value of the unit sample is at the point at which the argument is 0, we see from the figure that the running sum in equation 1.66 is 0 for n is less than 0. N is less than 0 here. This is okay, not here, sorry, not here, here only. Okay. Then we see from the figure that the running sum in equation 1.36 is for is 0 for n is less than 0 and 1 for n is greater than or equal to 0. Here when n is equal to 0, that time only gm equal to 1. Here also same like this. Furthermore, by changing the variable of summation from m to k, changing the variable summation m to k, that is m to k equal to n minus m in equation, that is m to k, that is n minus m. Okay, n minus m in equation 1.66. We find that the discrete time unit step can also be written in terms of unit sample. We find that the discrete time unit step can also be written, that is unit step, not unit step, this one unit step, can be written in the unit samples as e of n equal to k equal to, because m to k changes. Okay, so m to k equal to infinity to 0 del of n minus k, n minus this is, then this m to k, that's why m to k. We find that the discrete unit step can also be written in terms of the unit sample as like equivalently for this equivalent we have n. So here only changes k equal to 0 infinity to 0. It means this is reverse, so this is correct, 0 to infinity. Okay, equivalent. This is 1.67. Here relationship given equation 1.67, n is less than 0, n is less than 0, a n is less than 0.